Okay, so let's walk through the sorting challenge. So we had a function here called sort that takes an array that should sort a bunch of numbers. And if it gets an array and a Boolean value that is set to true, it should do the reverse sorting. So let's look at my solution here. Okay, so what I do is that I grab the array and the reverse Boolean, and then I return array.sort, which takes a lambda function that takes some value of A and some value of B. And first I check if I need to reverse the order, and if I need to reverse the order, I will take B minus A, and otherwise I will do A minus B. And what's beautiful about this is that in the sorting algorithm, basically what happens is that if you return a positive value, you will sort it in the, well, virtually the, I think it's the ascending order, basically. No, it's the, sorry, descending order. And if you return a negative value, you will simply do it in the ascending order. You will do it in the reverse. And if the number that you return is 0, that means that these two elements are equal. In other words, they won't switch places because they are, in the sorting algorithm's perspective, the same thing, or they should be sorted equally. And that's the basics of this algorithm. Easy peasy. So what's going on up here? Well, I just wanted to show you that this implementation here works very nice for numbers, because you can just subtract one number from another number, because if B is greater than A, then it's going to be a positive value, and otherwise it's going to be a negative value. So you kind of get a little bit less code with this implementation. And you could do it this way as well, where you basically just check if A is greater than B and there is a reverse, then you return -1. Otherwise you do B greater than A and reverse and return A1. And if it's not a reverse, you do it in the opposite direction, where you just, yeah, that's basically it. Now the thing with this is that because strings can actually be compared with the greater, like this Boolean operation, it's fairly straightforward to do a string implementation as well. And if I just grab this function here and I do this, and I run all my tests, and you can see that they're all passing. Now, I will make a little bit of a philosophical statement here, and you may think this is a very trivial example, but I will argue that this approach here might be slightly more on the money than this implementation. It's nothing wrong with this implementation, but this is a philosophical topic. So the requirements that we have declared in our tests is to make a number, or an array of numbers, to be possible to sort, basically. Which this is like this is the least amount of code that at least I know of that you can use in order to achieve that goal. This is more code, and it's the intention behind this function is to be able to sort both numbers and strings, which is out of scope. What do I mean by out of scope? I mean that this function does more than we have declared in our tests, and we should strive to write the least amount of code we can write to achieve the goal that we have set in front of us. The task at hand should be solved in the least amount of code that we can produce, because statistically, the more code you write, the more likely you are to make mistakes. So this is, if you did it this way, it's fine. It's absolutely fine. But I just want you to take this with you, because try to avoid writing more code than you have to achieve the goal that you have. Always go for the perfect implementation to solve the problem that you're trying to solve. Well, perfect implementation is a strong word, but at least try to write the least amount of code and make the solution that you have the least complex. Always go for simplicity whenever possible. Have a great day.